So I had skipped over number 5 last time because we were right at the end of class and I was like, I can't do all of number 5 in 2 minutes. So we had gone straight to number 6. So I'm going backwards to number 5. And this one, I couldn't make it not look exactly like a homework question, so I just kept it. So it is one of the homework questions for Dr. Whitener's class, but I also, someone very nicely sent me these solutions that she had posted. So I feel less bad about it because if that's all been posted, then it's not anything that was secret. So this one was talking about survey of registered voters, and I went ahead and kind of shortened it because there were a ton of words in that problem. So I took some of the words out of the problem. It said a survey reported that 61% of registered voters approved of same-sex marriage. Among 18 to 39-year-olds who were registered voters, the approval rating was 78%. 6 out of 10 registered voters said the Supreme Court ruling on Prop 8 was important to them. And out of those registered voters who support same-sex marriage, 75% said the Prop 8 ruling is important to them. There's a lot of words in that paragraph, and that was with me taking a bunch of words out of the paragraph. So what's difficult about a lot of the statistics stuff is that you have to read it a few times. And sometimes I use different color pens to kind of keep track of different things along the way. Highlighters are also a good deal, like to try and keep yourself focused on particular words in the problem. So if you have different highlighters, also something that might be helpful. As you're going through the problem, they want us to let A be the event that registered voters are 18 to 39 years old. Event B to be registered voters who say the Supreme Court ruling is important to them. And C is the event that registered voters support same-sex marriage. And we're going to use those letters when they're asking us for the probabilities in here. So the first one says find the probability of C. And C is registered voters who support same-sex marriage. So I want to go through the words here and see if they gave us any information on registered voters who support same-sex marriage. The survey reported 61% of registered voters approved same-sex marriage. That's the one that I want. So this is my C. Okay. Probability of C, I'm going to write this with a decimal. So probability of C, you are going to write as 0.61. Is that okay? All right. Next thing says find the probability of B. B is registered voters who say the Supreme Court ruling is important to them. So, no. 6 out of 10 registered voters said the Supreme Court ruling was important to them. 6 out of 10. They gave us as a fraction. How can I write that as a decimal? So 6 out of 10. 6 out of 10. 0.6 or 0.6 or 0.60 is also cool. 6 out of 10 means the same thing as 60%. How is that the case? I'm allowed to add zeros as long as I add the same number of zeros to the top and the bottom here. See how that became 60 out of 100? And percent means per 100. So when I add the 0 on there, I'm like, oh, okay. So that's 60%, which you can write with the 0 or without the 0. 0.6 is also cool. Okay. All right, slightly trickier. Find the probability of C given A. So with that line in there, they're saying given that A is already been established, what's the probability of C happening? Probability of C given A, we have a formula for that. That's going to be the probability of C and A divided by the probability of just A. Now, in this particular case, if they gave us a C and A and a probability of A, then we'll do that. If they actually give us C given A with the words, you have no calculations to do. So sometimes you're going to have to be hunting for a C and A and then find probability of A. We know we already have that. But if it's actually in words given to us, well, we won't need to use a formula. So let's just read and see what we've got. A is registered voters who are 18 to 39 years old. So we're looking for something that's talking about registered voters who support same-sex marriage, given that we already know they're 18 to 39 years old. So when I've got that last line up there, out of those registered voters who support same-sex marriage, 75% say Prop 8 ruling was important to them. That doesn't say anything about their age happening here. Among 18 to 39-year-olds who were registered voters, the approval rating was 78%. So we're looking for probability of them supporting same-sex marriage. That's approval rating, given that we already know that they're 18 to 39. And so that actual line, we don't have any calculation we have to do because they said among people who are already that age group. So that's given that they're in that age group, the approval rating is 78%. So we have no calculation here. We get to just write 0.78. Sometimes there'll be a calculation. Sometimes there won't be. Now, I already just read the last line, and I know that they also gave it to us in that form. Out of those registered voters who support same-sex marriage, so when they support same-sex marriage, that's C. So this is saying given C, 75% say the Prop 8 ruling is important to them. So B is people who said that the Supreme Court ruling was important to them. So given that these people support same-sex marriage, that's given C, they said the Proposition 8 ruling was important to them. This is B given C. So that line right there, we get to actually go ahead and just say 75%. Again, in terms of a formula, you could write out the formula, but we actually don't need to do a calculation on this one. 0.75. Yes.
How'd you get 78%?
78%. So if it's confusing you that I wrote the formula there, I wrote that just in case they had given us things in a different form, but let me get rid of it because we didn't end up using the formula here. Probability of C given A. So I'm going to start with the A part. Given A, registered voters who are 18 to 39 years old. What we're looking for is people who are 18 to 39 years old. We already know they're 18 to 39. We are looking for people who say in that age group that they support same-sex marriage. So in this line, it said among people who were 18 to 39. So that's given that we knew they're that age already. How many approved of same-sex marriage? It was 78%. So that came straight from the words. I didn't have to do any calculations.
Thank you.
Mm-hmm. All right. So in words, what is C given A? It's going to be California registered voters who support same-sex marriage, given that they are already 18 to 39. So in the way that I would say, depends on if you want to write one of the things first or not, but I'll say California registered voters who support same-sex marriage from the group of voters who are 18 to 39. So in this problem, when we were asking about probability of C given A, I needed to know that they were 18 to 39. And then of the ones who are 18 to 39, which ones support same-sex marriage? That's C given A. In words, what was B given C? Our B given C were the registered voters who say the Supreme Court ruling is important to them. Given that we know that they already support same-sex marriage. So the C here, they support same-sex marriage. And we wanted ones who said that they were important to them. So I'm going to say registered voters who say, I'm just gonna say Prop 8 because that's the Supreme Court ruling, is important to them. From the group of voters who support same-sex marriage. Now we want the probability of C and B. So both things. C was that they support same-sex marriage, and B was that they said the Supreme Court ruling was important to them. C and B, we have a formula when we want to do an and. And so we're going to take the probability of C is the first thing they mentioned. So we're going to do probability of C times the probability of B given C. I know that I'm using different letters that are on there, but that's the formula I'm going to write. So let me write it so that it applies here. So we want the probability of C and B. We write it with the upside down U on there. And this is the probability of C times the probability of B given C. So probability of C, we took care of in part A. So probability of C is 0.61. Probability of B given C, you took care of in part D. So that's 0.75. And in a calculator, that'll come out to be 0.4575. So in terms of what that would actually be in words, this would be voters who support same-sex marriage and who say the Supreme Court ruling was important to them. The next one wants probability of C or B. So that's C-U-B. And so that's our formula where we take the probability of C plus the probability of B. And then we subtract the intersection of those two things. So the probability of C and B, which we just did in the last question. So we do have that value. So now we're just plugging things in. So probability of C we had in part A, that was 0.61. Probability of B was in part B, that was 0.60. And then we calculated in part G our probability of C and B, and we had 0.4575. So from my calculator, that said 0.7525. How you doing?
Sorry, what did you but I tried solving it on my iPad.com. How'd you get 0.7?
For the answer on this one?
No.
Nope.
Sorry.
For part D. Cool. So this one didn't require a calculation.
Oh.
We had to look just at the words in the problem. And so B given C, I'm going to start with the given part. The given C, given that the registered voters support same-sex marriage. So I'm looking for a line that says of the people who support same-sex marriage, or given that these voters support same-sex marriage, or among all the people who support same-sex marriage, then I want B to be true, that they say the Supreme Court ruling is important to them. So I'm looking for something that says out of all the people who support same-sex marriage, 75% said the ruling was important to them. Yay. And so that was in words. We just had to write the 0.75. So there was no calculation on that. That was literally just in words. Sometimes there's calculations because they don't actually give us the line we're looking for in English. And then we might have to go and find something else. And so I had written out a formula the first time and said, we might be looking for these words if we don't have the words that we want, but we actually had the words that we wanted. So that's the frustrating thing for statistics, is there's a lot of language and word problems in there that, like, you have to be able to pick through what the symbols mean in terms of the words they're using. And the ands and the conditional stuff, so the like A and B versus A given B, those are kind of, they're tricky sometimes to tell the difference between them. And so when it says given something, that's when we're only talking about the group that satisfies the given condition, then we're looking for the thing that came first in the statement. All right, the last part says, are C and B mutually exclusive events? Why or why not? So let's look at C and B. C says registered voters who support same-sex marriage. B says registered voters who say the Supreme Court ruling on Prop 8, which was on same-sex marriage, was important to them. Without you doing any calculation, mutually exclusive means these things cannot happen at the same time. How are we feeling about B and C being mutually exclusive? Yeah, that wouldn't make any sense, right? So like, intuitively, I know that they are not mutually exclusive, but what we want is for us to be able to mathematically show that. And when things are mutually exclusive, this is what has to occur. Mutually exclusive would mean that the probability of C and B has to equal 0. But in part G, you calculated the probability of C and B. In part G, when we did C and B, we got 0.4575. So because we didn't get 0, that's the mathematical reason why these things cannot be mutually exclusive. So I'm going to say, but in part G, we showed probability of C and B equals 0.4575. So C and B are not mutually exclusive. So when they ask you why or why not on these types of problems, it's not dumb to give an English answer out loud and go, well, obviously, if people are supporting same-sex marriage and then there's like a group of these same registered voters who are supporting a Supreme Court ruling that's about same-sex marriage, that it would be really weird if those were mutually exclusive. But really, they're looking for a mathematical argument. And so using the rule is going to be a stronger argument for you. There's nothing wrong with saying the things in English, but they're probably looking for you to show that we should have gotten 0 if they were mutually exclusive. And since we didn't get 0, that means they can't be mutually exclusive. Does that make sense? It's a little nuanced in how we do some of these. They're kind of like proofs. All right. Now I'm going to go back to the page that we did number 6 on, the very top. We did it right before the end of class because I said I wouldn't be able to get through all of number 5 in 2 minutes. That's true. There was no way I was getting through number 5 in 2 minutes, but I was able to do number 6. Number 6, we had talked about flipping a coin 3 times. And since these were independent events, the probability of me getting heads or tails didn't change on each of them. And so we ended up with 1/8 when we flipped the coin. And it didn't matter that I wanted to get heads on the first flip, tails on the second flip, and heads on the third flip. It's just 50-50 each time. We had 1/8 for that one. Number 7 is asking about a password. So let's say that you have to pick a password that has 4 characters. So I'm going to write 4 spaces there. 4 characters for our password. And you're allowed to have your password have a letter or a number in that space. So let's say that I just need you to pick one thing. How many different possibilities are there if it could be a letter or it could be a number from 0 to 9? How many letters are there? I know this, people are like, how many are there? There's 26 letters in the alphabet. And if I could say that you can have the numbers 0 through 9, sometimes people think that means there's 9 numbers, but there's 10 because 0 is your 10th number. So you have 26 letters possible and you have 10 numbers possible. So do you agree that 36 different options are available for that first slot? So 26 letters and 10 numbers were my options. That's where that 36 came from. It says the password consists of 4 characters, each of which can be a letter or a number. How many possible passwords are there? It doesn't say you can't have repeats. So because it doesn't say repeats aren't allowed, you have 36 possible ones for this one, and 36 possible ones for this one, and 36 possible ones for this one. And then we use the multiplication rule like we did in the last problem. So my answer is going to be 36 times 36 times 36 times 36, which is 36 to the 4th power, which is a really big number. I'm hoping I wrote it down. I did write down the really big number. You ready for it? You have 1,679,616 possible passwords that you can make. So when they ask you to make new passwords all the time, and they want you to have like 8 different characters in there, you can see how like randomly guessing someone's password is not happening. Like if you have 8 different characters in your password, you have even way more than this, like a whole bunch. You're not gonna guess it by chance. Unless you're my mom and you pick 2222 for all of your dang passwords. And I'm like, Mom, don't do that. So number 6 and number 7 were both things that we use the multiplication principle on. The next one, we're using a completely different rule. A committee of 5 people is to be selected from a group of 10 people total. So a committee means I don't care who you selected first. Like I'm not choosing a president and a vice president or anything like that. I'm just choosing a committee. I need 5 people out of 10 people to be on this committee. So order doesn't matter. How many possible committees are there? When we talk about selecting a certain number of things from another number of things and order doesn't matter, that's called calculating a combination. Order doesn't matter. And this has a formula that instructors write different ways. So I'm going to write it 2 different ways. N choose R is how we say that, N choose R. Another way you can write it is N choose R like this in a set of parentheses. They mean exactly the same thing. So if they write this or they write this, they both mean combination. And in terms of what the formula is, this is N factorial over R factorial times N minus R in parentheses factorial. That's our formula we're going to use. And the way we say this part out loud is N choose R.
How do we know when to use the combination rule and the one I use on number 7 and 6? Like, how do we know what instances to use?
So when we're talking about, I have a certain number of things and you're only picking a smaller subset of those certain number of things, and I'm asking you for the total number of possibilities of something out of a certain, by choosing certain number of something, that's going to be a combination. But in the ones for part, or for number 6 and for number 7, what they're talking about is different events happening, and you're coming up with the possibility for each of the events. And so the event that was happening was I flipped the coin 3 different times. And so I wasn't taking like out of all 10 times I flipped a coin, how many, it's not asking that. It's saying you flip the coin 3 times. What's the probability of getting a very particular thing? Heads on the first flip, it's 1/2. So we're not going to go to the combination formula unless I tell you something like, instead of a committee, I could say something like, you have 10 different possible flavors of soda and you're selecting 3 of them. Or you have a bin with 20 socks and you are selecting 10 of them. So it's out of a certain number, you're selecting a different number of things. That's when you're going to be going to your combination. And this is going to get even more confusing in a second when I talk about permutations, because their formulas also look pretty similar. So remember when we started this and I said, I really don't like probability? These are the things I don't like about it, is trying to pick which formula we're supposed to use. So if you're like, Jen, I'm confused, I'm like, I totally get that. It is hard to tell the difference. And so the best way to learn how to tell the difference between them is to not panic about it just yet and look at a bunch of different examples and see if you can start pattern matching. Like, it seems like whenever they do something like this, we're using this formula, but whenever it's something like this, we use this formula. But until you've seen a bunch of them, it's really confusing and it's hard to tell the difference. So we're going to do a bunch more examples. And I even made you a practice midterm that I will pass out that you guys can take home for the weekend, and I'll post solutions. So you'll have even more things to practice on. So you'll have more things to look at. Okay. Okay. We are at the stage where we have to figure out what to put where. I want 5 people from a group of 10 people. So the N is the 10. So I want the combination 10, choose 5 things. Which if I wanted, I could write 10, choose 5 like this. Which is going to be 10 factorial divided by 5 factorial over 10 minus 5 factorial, which is just another 5 factorial. Okay. Calculators usually have a way for you to get a factorial. If your calculator does not have a way for you to get a factorial, you don't actually need your calculator to be able to get you a factorial. You need to know what 10 factorial means. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial times another 5 factorial. Part of this is easy because the 5 times 4 times 3 times 2 times 1 that's on top can cancel one of those 5 times 4 times 3 times 2 times 1's in the bottom. So I can get rid of all of these things. And so then if I didn't have a button in my calculator, I could just do 10 times 9 times 8 times 7 times 6 and divide it by 5 times 4 times 3 times 2 times 1. It still feels like a lot, but it's not terrible. Anyone get a number? Okay, so let's do, I'm gonna do 10 times 9 times 8 times 7 times 6. Nope, I did that wrong. 10 times 9 times 8 times 7 times 6. There we go. 3240. And I'm going to divide that by 5 times 4 times 3 times 2 times 1 is going to be 120. So I'm taking 30,240 and dividing it by 120. And I got 252. Did anyone else get 252? Okay. These are a little tricky. Yeah.
Before you move on, can you explain how you did the multiplication on the top and bottom, like the 10 times 9 times 7?
Yeah. So 10 factorial, the definition of 10 factorial is 10 times 9 times 8 times 7 times 6, all the way down to 1. The definition of 5 factorial is we're starting at 5 and go down to 1. And since there's another one, I had to start at 5 and go down to 1 for those as well. So then calculation wise, because I recognize that I have a 5 times 4 times 3 times 2 times 1 up on top, I was able to cancel out one of those factorials entirely and like, oh, cool, that's gone. And then I just did that part. So you can simplify it on yourself. You wouldn't be wrong if you multiplied all those out, put that number on the top, then multiplied this out, and then multiplied that out, and then divided at the end. You can totally do that, but sometimes it's nicer to get rid of some of them. And then some of you have a factorial button. And when you have a factorial button, you don't have to do any of that. Let's see, does my phone have a yes, my phone has a factorial button. So it's super small, but my factorial button is right there. It says X with an exclamation point. So if I want 10 factorial, I would put 10 and then hit that X with an exclamation point, and that gave me the number, nope, yes, that gave me this one because I didn't actually calculate that out. And then if you want 5 factorial, you'll hit 5 and then the X with the exclamation point. Depending on your calculator, you might need to hit the factorial button first. Usually you'll put the number and then the factorial button. Okay. Let me read you the next one, and then you're going to help me figure out what am I using. A student has 4 exams, and each exam has 5 possible grades you could get. So you could get an A, a B, a C, a D, or an F. Those are the 5 possible grades that you could get. How many possible combinations of grades are there for 4 exams? Am I using a combination, or am I doing something like I did for number 6 or 7? So I'm not asking you, out of all the possible whatever, we're only selecting blah. I'm saying you have 4 exams. 1, 2, 3, 4 exams. And what are the possible grades that you could get on the first exam? You have 5 possible grades you could get for the first exam. And you have 5 possible grades you could get for the second exam. And you have 5 possible grades for the third and the fourth exam. So this is like number 6 or number 7. And then we use our multiplication rule. So this is going to be 5 to the 4th power, which would be 625. All right. The next one you don't know how to do yet. So I'm going to read you the problem, and I'm going to explain why you don't know how to do it yet. And then I'll explain how to do it. Okay. So you don't know how to do this yet. Don't freak out. A music festival lineup features 8 bands. And the festival organizers want to schedule 4 bands to perform each day for 2 days. How many different ways can the bands be scheduled? In this case, I'm not asking you to randomly select 4 bands and randomly select 4 bands. I'm asking you on day 1, which order are these 4 bands going to play in? So when I did combinations, I was just selecting groups of things, but I didn't actually end up caring what order. So when I made the committee, I don't care what order the committee is in. I don't care who I selected to be on the committee first. Like, woo, you're committee member number 1. Like, no one cares. You're just on the committee. But for this musical lineup, I need to know who's playing first. The order matters. So that's different than a combination. That's called a permutation. And so that's a different formula. So permutations are where order does matter. Okay. And the formula looks really similar for NPR. This is a permutation, and it has the n factorial in the top, and the thing that it has in the bottom is just n minus the r factorial. It's almost the same, but it's missing the r factorial that's sitting in front of the set of parentheses in the bottom. So what this does is it actually creates more numbers for you, because when the order matters, you actually have more ways that these things are going to be arranged. So I just want to talk about the first day of the concert. So first day of the concert, I want to schedule 4 bands to perform. Okay. So on day 1, out of the 8 bands, I'm choosing 4 of them, and the order matters. So that's going to be permutation 8, choose 4. So out of all 8 bands, we're choosing 4 of them for the lineup. Okay. So in terms of my formula, that's going to be 8 factorial over parentheses 8 minus 4 factorial, which is 8 factorial over just 4 factorial. In terms of numbers, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is going to get divided by 4 times 3 times 2 times 1. And so you'll see that I can actually go ahead and cancel a bunch of this, which means my answer is going to be 8 times 7 times 6 times 5. So I got 1,680. So on day 1, there's 1,680 ways I can arrange those first bands. Okay. And then on day 2, I've got how many bands haven't played yet? 4. So now we're doing permutation 4, choose 4, because I don't need all of the 8 bands to select from anymore, because 4 of them already played. So this will be 4 factorial over 4 minus 4 factorial. So that's 4 factorial over 0 factorial. Did you talk about in class what 0 factorial is? 0 factorial is always going to come out to be 1. Why is it going to come out to be 1? That's a really good question. They just had to define it to be something. So I promise I'm not lying. If you take 0 and you hit the X factorial button, 1 popped out. So that's just a definition that you would want to memorize. So this is just going to be 4 factorial over 1 then, which is 4 times 3 times 2 times 1. So that's 24. So day one, there were 1,680 ways I could arrange the bands. And then the next day, there were 24 ways I could arrange the bands. But between the 2 different days, I could arrange any of those bands any way that I wanted. So the order on that one, I'm going to just multiply those 2 things together to get my total. Let me double check that. Yep. Yeah, 1,680. Actually, let me think about that for a second. Should I be adding them or should I be multiplying them? I could arrange the first set and then the next day I had 24. You're right. It would just be adding for 2 days, not multiply. So 1,680 plus just 24. $1,704 ways. All right. What am I doing? Still got time. Good. All right. 11. A factory produces 3 types of products, and each product can be made in 3 different colors. How many possible combinations of products and colors are there? Am I using a permutation, a combination, or something like we did in number 6 and 7? So if it's a combination, I have a certain number of things and I'm choosing a certain number of things out of those certain number of things. Or I have a scenario where I have a certain number of things and I have a certain number of ways each of those things can be. And that was when I did that. In this case, I have 3 types of products, 1, 2, 3. And each product can be made in 3 different ways. So we have 27. So what's confusing here is that they're using the word combinations, right? So it makes you think it should be combination, dang it. But it's not always that we're going to go to that formula for combinations. When we want a formula, it's that you have a certain number of things and you're choosing a certain number from that. It's very confusing. Okay. We got a Venn diagram here. And the Venn diagram is talking about students who are in they're in the international club and who speak different languages. So it says that we have 105 members in the international club. So if I added up all of the numbers here, those would all add up to 105. It says many of them speak multiple languages. The most commonly spoken languages in the club are English, Spanish, and Chinese. Use the Venn diagram below to determine the probability of selecting a student who does not speak English. So looking at the picture, if I want to select a student who does not speak English, I have to add up all of the ones that are not in this circle in any way, shape, or form. Because even if they're in this part over here, they still speak English because they're part of that circle. So if they don't speak English, I have 7 plus 3 plus 2 plus 4. Does that make sense? So 10, 11, 12, plus 4 more, I got 16. So probability, I'm gonna put English complement. Is that okay? Don't speak English would be the complement of those who do speak English. And that's gonna be 16 out of our total number of students was 105. How'd I get 16? So they cannot be in the circle that's for English. So I added anything that was not in this circle. So 7 plus 3 plus 2 plus that 4 that's sitting out here. The 4 that's sitting out here, this is a student who doesn't speak Spanish, Chinese, or English. They speak a different language. All right, we want a probability that the student speaks Spanish given that the student speaks English. So probability that they speak Spanish given that we know they speak English. So what number is going to be my numerator here? So speak Spanish, given that they speak English. So that means I have to be inside the circle for English. 33 plus 8. Yep. So that's going to be 41 for my numerator. And my denominator has to be all of the ones who speak English. So it's going to be 33 plus 8 plus 13 plus 35. Which is 89. Okay. Now we want the probability the student speaks English given that he or she speaks Chinese. So probability they speak English given that they speak Chinese. So now I'm in the circle for Chinese. Probability that they speak English would be 13 plus the 8. Is that okay? So 21. And my denominator is going to be all of the ones that are in the circle for Chinese. So 3 plus 2 plus 8 plus 13. So 26. All right. And now we want the probability the student speaks Spanish and English, but not Chinese. So speaks Spanish and also speaks English, but they don't speak Chinese. So Spanish and English, but not Chinese, because over here they speak Spanish and they speak English, but they also speak Chinese. So it's just going to be that 33. Good. So 33. And then what's my denominator on this one? I don't actually know what to put for my probability here. Probability of Spanish and English and not Chinese. I'm just going to not put my probability. So 33 goes in the top. This one, you're not saying given anything. So you're putting the 105, which is the total number of students.
For the denominator, why don't we take out the word because they don't speak any languages?
So for this particular problem, so when we're asking this question, we want the probability that you, of all the students that you could select from, so you have 105 you could select from. Out of all 105 students, what's the probability you happen to pick a student who speaks Spanish and English, but they don't speak Chinese? And so it's out of all the students, because I haven't said anything specifically like, given that they speak English, that's the thing that changes your denominator on you. But if I haven't done that, then it's going to always be out of all of the possible. Good job, folks. Happy happy Friday. If you go to picnic day tomorrow, don't forget sunscreen. That was my rookie mistake when I went to my first picnic day and I got terribly sunburned. So don't forget the sunscreen. Also drink water because even though it's only supposed to be like 80 something, if you're out in direct sunlight for hours and hours and hours, you can get very dehydrated. Have fun. If anyone pressures you to do bad things on picnic day, just say no and say, I have to go to Jen's class on Monday. I'm not doing any of those things.
And explain C again.
No problem.